Let's say we have a bunch of vectors, v1 through vn. We multiply each of them by a scalar, and we add the results up. That's called a linear combination of the vectors v1 through vn. And the scalars in this context are called the coefficients. So the coefficient in this case of v1 is alpha 1. So here's a simple example. The one linear combination of these two vectors is this. Multiply the first one by -5, the second one by 2, and add the result. So it's equal to this. Now, another linear combination of the same vectors is multiply the first one by 0, the second one by 0, add them up. And of course, you end up with the all zeros vector. A linear combination where all the coefficients are 0 is called the trivial linear combination. There's a factory called Junko that makes a bunch of products. A garden gnome, a hula hoop, and so on. Here's a table that specifies for each product how much it uses in each of 5 resources. For example, making a garden gnome takes 0 units of metal, 1.3 units of concrete, and so on. So for each product, we can write down a vector that specifies how much of each resource it uses. So for example, for making a garden gnome, the vector maps metal to 0, concrete to 1.3, and so on. So there's a vector like this for each of the products that Junko makes. Now, suppose the factory decides to make alpha 1 garden gnomes, alpha 2 hula hoops, and so on. Then the total amount of each of the resources is specified by a vector that can be expressed as a linear combination of the vectors v1 through v5. In fact, I don't know how much of each product Junko makes. That's what I want to find out. I want to carry out industrial espionage to figure out exactly how many garden gnomes Junko is making. How can I do that? Well, let's say I know how much of each resource they're consuming. I know the vector b in this equation. And I know the vectors v1 through v5, because I know how much resources making a garden gnome requires. I want to figure out alpha 1 through alpha 5. How can I do that? This raises the following computational problem. Given a vector b and a list of vectors v1 through vn, can you compute the coefficients with which b is expressed as a linear combination of v1 through vn? And even if we can compute that, am I going to get the right answer? In fact, is there a single right answer? Here's another example. Recall lights out. I'm going to use, for simplicity, I'll use the 2 by 2 lights out as an example. Here are the button vectors for lights out. And here's an initial state vector. For this initial state vector, I want to know, how do I solve the puzzle? In particular, which subset of the button vectors have to be pressed in order to transform this to the all lights out state? We can express that problem in terms of linear combinations. We write the desired state vector as a linear combination of the button vectors, and we ask, what values of alpha do I need to make this true? Okay, and here's the solution. We know that solving an instance of lights out can be transformed into the question of which set of button vectors add up to the target state S. A more general version of that is, given vectors v1 through vn, which subset of those vectors sums to a vector S? And we see that this question can be reformulated as the question of how to express S as a linear combination of v1 through vn. So we can solve that puzzle if we have an algorithm for the following computational problem, expressing a given vector as a linear combination of other vectors.